Hey everyone, welcome back to another episode of the Weekly Coder. I'm Chris, and today we are going to continue playing our, we're going to continue creating our Pong Clone so that we can one day play it. We are going to add the ball to the screen, or to the scene rather, and we are going to make that ball move in the direction of the player paddle, and then bounce back and come to the computer paddle. And for now, all our ball is going to do is just kind of bounce back and forth between the two paddles. We'll be able to move the paddles, but the ball isn't going to deflect off at any particular angle. That is going to be for the next video, and that's going to involve a little bit of trigonometry, and don't worry, I'm going to do my best to explain it, how it works and why it works. But first things first, let's get the ball moving on the screen. And what I've done here, and I'm thinking that this is from a previous tutorial, I don't know, but I created an empty here. Okay, so I just did game object, game object, create empty, and I've called it game, and then I've attached our game script to the game object. Okay, so right now our game script is pretty much empty. There's nothing in it. Okay, so the first thing that we're going to want to do is when the game loads, we are going to want to instantiate our ball, okay? Because our ball is, as you can tell, not part of our scene. It's just a prefab sitting in the resources folder. So let's go ahead and instantiate our ball. So what we're going to do in the game class, we're going to create a private game object. It's only accessible to the game class, and we are going to call this game object ball. Okay, easy enough, right? So then in the let's see here, what we'll do is we'll create another method. We'll call this one spawn ball, and then in the start method we are going to call this method and call spawn ball. If I could spell spawn ball. Okay, and in the spawn ball method is where we're going to instantiate our ball, and let's see, before we do that, let's create some actual variables in our ball class. Or you know what, no, we're gonna go ahead and instantiate the ball first thing. Alright, so we're going to set ball equal to game object dot instantiate, and instantiate is a method on the game object class. Okay, and we're going to cast game object as what we're instantiating from our resources folder. So we're going to do resources dot load, and then we're going to tell it, okay, well, we want to load a resource that's in the prefabs folder. So when you do resources dot load, it's going to automatically look in the resources folder. So then we've got our prefab stored inside the resources folder inside a prefabs folder. So that's the first thing we're going to type is prefabs, because that's where we want to look. And then we've got our ball in the prefabs folder. And we're going to also tell it what type of resource we're going to load. So this is going to be type of game object. And then we're going to close up our parentheses, and that's that. So then what we want to do is, because we don't want Unity to decide, okay, well, where are we going to put this ball? We're going to tell it where we want the ball to be. So we're going to do ball.transform.local position equals new vector 3. Okay, and the x we're going to pass it, let's try 12. We're going to be 0 in the y because we're going to just center it. And we're going to do -2 in the z, so just to make sure that it's in front of everything. Alright. So we save that, and the way we have it now, we should be able to go back into Unity, press the play button, and the ball should appear on the screen. And there it is. And it's right in front of the computer paddle, okay? So as to look like it's starting off from the computer paddle, and it's going to bounce this direction. So right now, the ball itself isn't moving at all. It's just sitting there statically, just not doing anything. So we can move our pedals up and down, and the ball just doesn't do anything. So we have to move the ball. So let's go ahead and open the ball class. Okay. And in order to move the ball, we have to define at what speed we want to move the ball at. So let's go ahead and start with that. We're going to make this public so that we can use it in the inspector so that we can modify the speed at will as we're playing the game so that we can kind of fine tune it. So we're going to do public move speed, and we're going to set that equal to 12.0f to start with. Okay. Public float. Don't forget to tell it what type of variable you want to create. So we're going to create a public float, call it move speed, and then tell it the speed that we want to initially use. All right. So now we should create a move method, and this method is actually going to move the ball. And it's very simple. So we're just going to say transform. So we're going to get the transform of the object that the game script or that the script is attached to. So that would be the actual ball itself. So we're going to set the local position, and we're going to increment it by our. We're going to need the move direction. Okay. So we need to tell the ball which direction it's going to move in, right? So we're going to create a another variable, and we're going to call this, we're going to make it public, and we're going to use a vector2, and we're going to call this one ball direction, and we're going to set that equal to vector2.left. Okay. So initially our direction is going to be left, and that just means that we have an x of -1 and a y of 0. So we're going to say transform.local position, and we're going to increment that by the ball direction, so vector2.left, times the move speed, times time.delta time. And finally, in the update method, we are going to call our move method. Okay, so we'll save that. Now when we go back into Unity, our ball should be instantiated, and it should start moving in the direction that we've set up here at the speed that we've defined in here. So let's go ahead and try that out. And we have an error. And the error says the call is ambiguous between the following methods or properties. Okay, so we're trying to set a vector2 to a vector3, which it doesn't like, so we're going to cast a vector3 and press play. And the ball is moving. Alright, so that's great, but our ball just continues to move. And if we look at our scene, zoom out, we can see our ball is still moving, never ending, all the way to the left. But that's not what we want. We want our ball to actually collide with the paddle and then start moving in the opposite direction, and then collide with the paddle, and then start moving in the opposite direction. So we just want it to bounce back and forth between the paddles. So in order to do that, we have to know some things about our paddles. We have to know where they're currently at, how wide they are, and how tall they are, so that we can check a couple of parameters as the ball is moving. And that is going to require us to create another method as well. So let's go back into our ball script. We are going to create another method here. We're going to call this one void, or actually we're going to return a boolean. So we're going to do check collision is what we're going to call it. Okay, so we want to know if the ball collided with either of the paddles. And we're going to need a couple of variables, actually quite a few of them. So what we're going to create here are a bunch of floats. So we're going to create a player paddle height, player paddle width, a computer paddle height, and a computer paddle width. And you're saying to yourself, but Chris, why are you creating height and width variables for both the computer and the player paddle since they're the same width and the same height? Well, what if you wanted to create a Pong game where your computer paddle, I don't know, gets a power up in it, you know, or the player paddle, either one of the other, get a power up which extends the paddle's height or width. Or what if you want to create some crazy Pong game where your player paddle can get wider and, you know, take up more of the screen for extra difficulty or easier gameplay? Well, you know, when I build these games, I try to think ahead of and create those kinds of things so that we can manipulate the width and height of the computer and player paddles separately, even though they're the same size right now. So that covers that. So the other ones we're going to need are a player paddle max x, player paddle max y, player paddle min x, player paddle min y, and then the same thing for the computer paddle max x, computer paddle max y, computer paddle min x, and computer paddle min y. Okay. Oh, and two more. We need one for ball width and ball height. Okay, and that takes care of all of the variables that we are going to need for the specific type of collision that we're going to check for. Okay. So then we also need to know about our computer and our player paddle and where they're at. So the best way to do that is just create game objects and then set references to our game objects that are in the scene. So we're going to create some variables here. So game object paddle player, paddle computer. Okay. And we also need to be able to reference our actual game. Okay. So actually, do we need to reference our game? We do not need to reference our game right now, so we don't need to create that variable. Alright. So now that we've got our variables created, we can go down to our start method and actually set those up, right? So we can say paddle player equals game object find, and we're going to use the name of our game object right here, so player underscore paddle. So player underscore paddle, and we're going to do the same thing for the computer. Paddle computer game object dot find, and that one's called computer underscore paddle. Alright, so now we're going to set up all these: the player paddle height, the player paddle width, the computer paddle height, computer paddle width, the ball width, and the ball height. Okay, so we're going to get all those values right now. So player paddle height is going to be paddle player dot transform dot get component sprite renderer dot bounds dot size dot y. Player paddle width is going to be basically the same thing, so paddle player dot transform dot get component sprite renderer bounds dot size dot x. Computer paddle height equals paddle computer dot transform dot get component sprite renderer dot bounds dot size dot y, and computer paddle width paddle computer dot transform dot get component sprite renderer bounds dot size dot x, and for the ball width or ball height, it's going to be transform dot get component sprite renderer bounds dot size dot y, and ball width is going to be transform dot get component sprite renderer bounds dot size dot x. Okay, so since the computer and the player paddle are not going to be moving in the x direction, we can go ahead and set the max x and min x variables for both the paddles. And what I mean by that is we've got our paddle, that's our player paddle, for instance, and we're going to set a max x, okay, which is going to be the outside of the paddle that is going to determine, okay, so where is this max x going to be? And we're going to use that when the ball travels to the paddle, and we're going to say, okay, well, this is the maximum amount of space that the ball can move before we say, okay, the ball is colliding with the paddle. So that's what those variables are for. So we're going to say player paddle max x equals paddle player dot transform dot local position dot x plus player paddle width divided by 2, player paddle min x equals paddle player transform dot local position dot x minus player paddle width divided by 2. Okay. So the max x is going to equal the player paddle, okay, the local position x plus the paddle width divided by 2. Okay, so because the x is in the center, we have to take the width of the paddle and we have to divide it by 2 and add that to it. So that's going to be the max, okay? And then the min is going to be on this side, so we have to subtract half the paddle width. So now when we do the computer, paddle max x equals paddle computer dot transform dot local position dot x minus computer paddle width divided by 2, and computer paddle min x equals paddle computer transform dot local position dot x plus computer paddle width divided by 2. Okay, so those are our max x and min x variables. We're going to also have to set our max y and min y variables, but because the paddles are moving constantly throughout the game, we have to set those variables in the update method, in the actual check collision method, because that gets called at every frame, because those variables can actually change as the paddle moves. Okay, so in our check collision method, we are going to start with setting our max y and min y variables for the player and the computer. So we're going to say player paddle max y equals paddle player dot transform dot local position dot y plus player paddle height divided by 2, player paddle min y. Did I not get that right? Player paddle min y equals paddle player dot transform dot local position dot y minus player paddle height divided by 2. Okay, so it's going to check the current position of our player paddle, the y position, and it's going to add half the height of the paddle, again because we're the y position is going to be at the center of the paddle, so we need to get the height of the paddle and divide it by 2 and then add that to it to get that the max y. And then for the bottom, we have to subtract half the paddle height so that we can get the bottommost, the min y, right? So the same thing for the computer. So computer paddle max y equals paddle computer transform dot local position dot y plus computer paddle height divided by 2, and computer paddle min y equals paddle computer dot transform dot local position dot y minus computer paddle height divided by 2. Okay. So now that we've got our variables set up, we should be able to start with our logic, right? So we have to check, so if transform dot local position dot x, so this is the ball's x position, and we're going to subtract the ball width divided by 2. I'm going to check to see if that's less than or equal to the player max x, okay? And then we also have to check to see if it's less than, all right, or greater than the min, all right? So we go transform dot local position dot x plus the ball width, ball width divided by 2 is greater than or equal to player min x, okay? So basically what that if statement does is it takes the local x position of the ball, it subtracts the ball width divided by 2. So basically you've got your ball, right, square, and then we've got transform that local position at x, which is in the center of the ball. We take half of the width of the ball, we subtract it, so then that gives us a value that's over here on the left side of the ball. We check to see if that's less than or equal to the player paddle max x, which we've got our player paddle, right? Got our player paddle, and the max x position of the paddle is on the outside, the far outside. So we're going to check to see if the position, right, once it gets here, is it less than, because we're moving in the negative direction, is it less than or equal to max x, okay? And because we also want to check to see if the ball is greater than the min, right? So is this ball greater than the min of the paddle? Because if it isn't, then it's traveled past it, right? And the only times it can travel past it is if it's above the paddle. So if it's traveled past it, if it hasn't traveled past it, and it's just past the line of the paddle, then we have an x collision. Now we have to check if we have a y collision, okay? So we do if transform dot local position dot y minus ball height divided by 2 is less than, is less than or equal to player paddle max y and transform dot local position dot y from that local position plus ball height, plus ball height divided by 2 is greater than or equal to player paddle min y, okay? Alright, so we know we've got an x collision if we're in this if statement. So then we're checking to see the ball's y position, okay? Is the ball's y position minus the ball height divided by 2, so we take the ball height, is that even right? The ball height divided by 2. Oh yeah, because we have to check the bottom of the ball against the top of the paddle. So that's why we're subtracting half the ball height, because we want to check the bottom, okay? And if the bottom is making contact, we want to also check to make sure that the top is also making contact with the bottom of the paddle. And if that's true, then we have a collision on the x-axis as well as the y-axis, which means we definitely have contact with the ball. So because we've created this check collision method, as a Boolean, we have to return true or false. So in this case, we're going to return true. But before we do, we know that the ball collided, so we want to change its direction to go the opposite way. And we know that if it collided with the player paddle, that it was going left. So now we have to tell it, okay, well, you know what? Since you collided with the player paddle, you're now going to go right. So what that looks like is we're going to just say ball direction equals vector2.right. And then there's one more thing we have to do. Since the ball collided with the paddle, okay, and we don't know where exactly it collided with the paddle at, we want to make sure that it looks like that it hit the outside of the paddle and that it doesn't start from the inside of the paddle when it starts to go the opposite way. Because what will happen is depending on your move speed, okay, the ball isn't always going to exactly line up, and that's why we don't check to see if the ball position is equal to the paddle position. We check to see if it's less than, because it can be less than. Okay, so if it is, then what we're going to do is we're going to set its position to be that of the max x position of the player paddle. So we're going to say transform dot local position equals new vector 3. Okay, oops, that's not even right. New vector 3, and the x position is going to be the player max x plus the ball width divided by 2. The y position is going to be the transform.local position.y, and z is going to be transform.local position.z. Alright, so those don't change. It's just the x position. So the ball width, player max x is going to be on the outside, and we're going to do should be minus ball width divided by 2. Wait, no, plus ball width, because we're actually not, okay, so that makes more sense. We're adding the half of the ball width so that the center of the ball is going to be at that position where it needs to be. So now if we save this, and we go back to our Unity, and we click play, we have errors, because why wouldn't we? Oh, we're not returning a value all the time. Alright, so at the very end of our check collision, we have to actually return false, because our check collision is going to be actually called right here, move. So we're going to do if not check collision, meaning that check collision is returning false. We're going to update the position of the ball. Okay, so we're going to make the ball move as long as check collision, okay, is okay. So we have to. Okay, so yeah, we're going to see what happens here, but basically we're saying if check collision equals false. That's a method. If check collision equals false, then we're going to continuously move the ball. If it equals true, we don't move the ball. Okay? So let's see what that looks like. And the ball gets stuck. And the ball gets stuck because when we're checking our collisions, we're doing less than or equal to. So what we actually should do is we should remove the less than or equal to. So let's remove that. So only if it's less than or greater than or less than or greater than here. Alright. So now it's not going to bounce back because obviously we haven't checked collisions for this yet. So let me show you what happens if we move the paddle. Ball just keeps going. Okay? So that's the exact behavior that we want. So what we're going to do now is we're going to go ahead and do the computer paddle as well. So basically it's going to be the same kind of collision detection except for it's going to be reversed. So transform dot local position dot x plus ball width divided by 2 is greater than computer max x, and transform dot local position dot x minus ball width divided by 2 is less than computer paddle min x. Okay, we know we're colliding in the x-axis. We check y, so transform dot local position dot y minus ball height divided by 2 is less than computer paddle max y, and transform dot local position dot y plus ball height divided by 2 is greater than computer paddle min y. Then we know we are colliding on the y-axis. So then what we do is, again, we change the ball direction, set that equal to vector 2 dot left, and then we set our position, so transform dot local position equals new vector 3. That's going to be computer paddle max x minus ball width divided by 2, and then transform dot local position dot y and transform dot local position dot z, since those don't change, and then we're going to return true. So again, if we're colliding with computer, we don't want to move. If we're colliding with player, we don't want to move. If we're not colliding with anything, we want to return false, so we're going to continue moving. So we'll save that, and now when we press play, our ball should bounce between the player and the computer paddle. Alright. And goes back. Alright. So, where do we go from here? I think from here we go to the next tutorial, honestly, because we've actually done quite a bit in this one. Next week we're going to get into ball angles and using trigonometry. Yep, so we'll look forward to that next week. If you guys enjoyed the video, give it a thumbs up, and don't forget to, comments go down below, and please subscribe to my channel. I'll see you guys next week.